Okay. Bismillahirrahmanirrahim. Assalamualaikum and a very good morning to all. I think we are live today. And first of all, I would like to wish you a happy weekend for all. So for today, Alhamdulillah, in Faculty of Agriculture, we will have a free webinar for today. So I would like to introduce to you our speaker today. He is Associate Professor Dr. Christopher Teh, Boon, and basically he has earned his PhD in agriculture at the University of Reading, UK in 2001. He is now a lecturer and an associate professor at the Faculty of Agriculture, University Putra Malaysia, and he focuses, he teach soil science and crop modeling and climate change. Apart from teaching, he was also the project leader for over 20 national and international research grants. He has published over 50 scientific journal articles, 8 book chapters, 5 books, and nearly 80 scientific conference proceedings. Associate Professor Dr. Christopher also regularly involved in disseminating gardening advice. He has been invited for talks and has organized gardening workshop for urban gardeners. He was a regular contributor for Dear Plant Doctors, um, a monthly column in the Star newspaper for promoting and helping urban gardeners. And this column has run for 10 months in 2017. He also was a regular contributor for two gardening articles for the local newspaper SJ Echo. So that will be the brief introduction about our speaker today. So without further ado, I would like to pass to Associate Professor Dr. Christopher to deliver the webinar today. Please, Doctor.
Thank you, Dr. Susi, for the kind introduction. And thank you, audience, for taking a little time off during this free Saturday to attend this webinar. This is the first, it is a part of the series. This is the first of the series on community webinar organized by the Department of Land Management under the Faculty of Agriculture, UPM. So let me share my slides. Okay, so I hope that you can see these slides and especially the arrow. Please let me know if you have problems having difficulty in watching this. Okay, so the title today, as I said, this is the JPTH is Jabatan Pengurusan Tanah. It is the Department of Land Management community webinar. So this is the first. There will be many more about once every 2 or 3 weeks. So the title is Wash Rice Water as Liquid Fertilizer, a myth or fact? And most importantly, what does science say? I think all of us, we all eat rice. Malaysians eat a lot of rice. And if you are Filipino, you even eat more rice, much more rice. And when we eat rice, before we cook, we always wash it to remove the dirt and excess starch and so on. And the color is this milky or creamy white. And we call it liquid. Some people call it liquid white gold. Why white gold? White because, well, it looks white. Why gold? Because it's precious. And liquid, of course, is washed rice water. But it has different names. In Indonesia, they will call it sometimes air cucian beras or air leri beras. And in Philippines, they call it ugas bigas. I think it's Tagalog. So the idea is this water that is left over after we wash rice, very normally is just thrown away. Of course, gardening enthusiasts like yourselves, you will store it and wash it, and apply it, water it to your plants. So at the end, is it really that beneficial? Of course, people may say, our neighbors may say it is good, our friends may say, even our parents and grandparents will say it's beneficial. But what does science say? So washed rice water is claimed to be beneficial because when we wash the rice, the nutrients in the rice, the grain, the solid rice grain are washed out, or we call it leached into the water. So that nutrients that has been lost from the rice grains is claimed can be applied as a plant fertilizer, therefore a beneficial plant fertilizer. But surprisingly, scientific evidence of these claims are lacking. Not lacking because we didn't, not lacking because the science show that it's not good. It's just that it is not done in detail, not studied in detail or in a scientific, rigorous manner. So sometimes you may, on the internet, you may see blogs or articles about the benefits of washed rice water, but that is almost always done without a proper, rigorous manner, scientific manner. You cannot just simply add water, washed rice water in a plant and say, oh, it's very healthy compared to my next plant that is not applied just with tap water. There is a proper way to set up the experiment, to lay out the experiment, to analyze the data, and so on. That is lacking even until today. So the claims of washed rice water as a beneficial plant fertilizer is more based on experience, anecdotal, more stories, based on stories and so on, rather than hard science fact or science evidence that shows that we did this research and found that blah 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 is good or not good. But it's more anecdotals. What people say, what's claimed, what our neighbors say, what we think we say, because we have to do the experiment in a certain way to remove the external factors. So we only study those factors that we apply, and then we see what is the outcome. And we did a search on papers, research papers on WRW is washed rice water. There are only 41, not last year 41, 41 papers only on washed rice water. And out of that, 10% or four papers is published in a reputable scientific journal. The rest, 90% either in low-ranking journals or just as undergraduate final year research reports. Now, I don't want to put down these papers that are undergrads. They are doing what they are doing. They are undergrads. Of course, they write a final year research. But this is what I trying to show, that the study on washed rice water is surprisingly very lacking. And only 41 papers we found. And I said not 41 papers published last year. 41 papers since the beginning of time that I've managed to find. And most of them, 10%, 4 papers, is only in high-ranking scientific journals. Okay, so, well, you can buy washed rice water from Shopee, but not in Malaysia. Shopee Indonesia, they sell by bottles. It's about 3 ringgit 50 cents. And very curiously, it is not white, not the familiar color we are used to, that is creamy white or milky white. It's orange, sometimes very dark red, dark brown, almost to the color of black. And why orange? This is because they add brown sugar or molasses or red sugar, or they add effective microorganisms. So it's not just washed rice water, they add certain things. Like this young boy, Rafa Azaran Fala, came out in the local newspaper in Indonesia, again, in Kalimantan. He's a young entrepreneur. He packaged his own washed rice water and he sells it for 1 ringgit 50 cents per bottle, about 500 milliliters. And look at the color. It's not quite consistent. Maybe, I don't know, maybe this is grade A, grade B. This is quite brownish, and this is light brown. Again, it has been added with sugar, with claims that the sugar will give fuel or food to the microbes in the washed rice water. Again, this is another university students. This one is a boy, I think, I'm not sure how old is he, maybe 12 years old. And this one by university students, Diponegoro University in Java. They also package it, POC, pupuk organic cair, liquid organic fertilizer. And the color again is not creamy white, added. So basically you can do it yourself. You can just wash your rice, add some molasses or add some sugar or effective microorganisms, and then you package it in a fancy bottle, print a fancy label, and then you can sell it for, I don't know, 150 to 3 ringgit 50 cents, and sell it at Shopee. But again, it's nothing complicated, nothing high technology or high skill. There's even instruction like this for every 1 liter of washed rice water, like this, almost white, white color, and then you add 100 grams of brown sugar, and then about 1 to 2 teaspoons or 1 cup of effective microorganisms. The reason they add all this is to encourage the growth of beneficial microbes in the washed rice water, and this is the fuel, the food for the microbes. So that's why they add the sugar. So you just add, mix it, very easy. What is probably unusual is this plastic jerry bottle, where you can, again, you don't have to use this, but it's easy. But you need to do a bit of customization. You need to make a hole, attach it to a tube, put the tube, submerge the tube into a mineral bottle with water. Why they do this is to leave it for fermentation. So they ferment by itself inside this bottle for 1 week. Then they say you can sell it or you can put it in your plant. Again, where's the evidence that this actually works? Again, it's all based on anecdotes, where it's just claimed that it's beneficial, claimed to be better, but how much better? Or is it better simply because of the they pay more attention to the plant? All right. And again, this is just one source, and you go to YouTube, you are blessed with, or rather cursed, or maybe perhaps cursed, because you have so much information about DIY, how you can do your own wash rice water formula, and it's almost always the same, always adding sugar and adding wash rice water, and adding effective microorganisms. Sometimes they do a bit of customization. Again, like this one, they add kulit bawang merah into their mixture. All right, so you use the Malay word air leri or air cucian beras. You get more hits than using the English wash rice water. So okay, at the end of the day, why bother? Why study wash rice water? If we know what we know, so how meaningful will be the results or the knowledge be? If tomorrow we find that wash rice water is, well, wow, very good, so why bother? Why learn? Well, Malaysians consume about 3 million tons of rice per year, and this number of 3 million tons does not include the consumption of rice in other forms, like making rice flour, rice noodles, and even the inclusion of rice into non-food products like cosmetics, animal feed, and and other byproducts. So this 3 million tons is just what we cook in a rice cooker and then we eat every day. But it does not include rice in the food industry, used by the food industry. And according to a recent survey, almost all, 97 Malaysians eat rice twice a day. If you're Filipino, it's probably 3 times a day. So Asians, basically, we eat a lot of rice. So even using just a conservative estimate, these 3 million tons of rice, if we wash it with the usual way, it can produce about 3 to 18 billion liters of washed rice water per year in Malaysia. And these 3 to 18 billion liters of washed rice water is simply just thrown away, poured down into our sink and into the environment. Now, it can be hard to picture how much is 3 to 18 billion. So this worked out to be about 0.4 to 2% of Malaysia's mean annual rainfall. Well, not to say a lot. So, but nevertheless, even though it's only 0.4 to less than 2% of Malaysia's mean annual rainfall, washed rice water should still be reused or recycled as part of water governance, so that wastewater, rather than just being discarded into the environment unused, it is instead reused, recycled, or treated. I like the comment by one of the Facebook user who said that when we wash rice, this water that is produced is better to use it rather than just throw it away. And it's always produced. It's not like we intentionally produce this wash rice water. As long as we eat rice and we wash the rice before cooking, this is the wastewater, and it's better to use it to do something about it rather than just throwing it away. So that is a good rationale why we study wash rice water. And secondly, global freshwater demand is expected to increase by 55% by the middle of this century due to climate change and increasing world population. Now, Earth is surrounded by 70% of water, but not all. Only less than 1% of that 70% of water is fresh water, directly usable. So Earth may be covered by a lot of water, but a lot of it cannot be used directly because of high salt content. What can be used is the fresh water, and the world does not have a lot. As I said, less than 1% of fresh or water is fresh water. And agriculture is the biggest consumer of water in the world. Agriculture uses 70% of the world's fresh water. So imagine the world's fresh water, 70% of it goes to agriculture. Then the rest, 30%, goes to other sectors. And just to give you an idea how much is 70%, agriculture uses 280 million liters of water per second for growing crops. This doesn't include for animals. So this is 280 million liters per second, not per year, per second. So 1 second, 280, 2 seconds, 560, and so on and so forth. And the FAO of United Nations says that more than half of our global fresh water is simply just discarded. We use a lot of fresh water, but we also waste a lot of fresh water. And municipal water, urban water, is 11% of that global fresh water withdrawal. And again, a lot is wasted. 8% is just discarded, and only 3% is used. So reusing wash rice water is a part of water governance. It's not the water governance. It's only part of the program or targets or achievement for better water governance. And if wash rice water is shown to be a good fertilizer, it can potentially reduce the fertilizer usage, particularly in the urban areas. So one part, water governance, and the second part can potentially reduce fertilizer usage if it's shown to be good. Even if it's not as good as normal fertilizer, it can reduce. So regardless, Indonesia has a lot of interest in wash rice water. Is part of sometimes even the local community, like in Pulau Julis in Indonesia, Bogor. This is a community initiative. Just by themselves, they decided to collect the waste, the wash rice water from everybody in the village, collect it, and then use it for watering and fertilizing the village crop. And this is not just them only, but in another part in Indonesia, Jawa, Lambang Kuning, as part of the local government policy, they collect wash rice water as part of the program for women emancipation for part of the national development. So the Indonesians are already doing it in some villages, as you can see here. So the questions that will be answered in today's community webinar are as follows. We want to know how much nutrients are there actually in wash rice water. We know nutrients are leached, definitely, but how much? Is it a lot? Is it very little to the point of being negligible? That is what we want to answer. Second, how does water volume and rice washing intensity affect the nutrient concentration in washed rice water? In other words, if we use a lot of water or if we wash very aggressively, does it affect the nutrient content? We think it will, but how much? Is it a lot? Is it a little? Or a lot of difference? That means if I use a lot of water, does it mean I dilute the nutrients? Or if I wash very aggressively, does it cause more nutrients to be leached out? We think it might, because intuitively, we think that if we wash it very aggressively, more nutrients will come out. And third, how does fermentation? This is a very important question because a lot of gardening enthusiasts, they don't just apply wash rice water as it is. Some of them do ferment it for sometimes 1 week, even 14 days. Does it affect nutrient content? Does it increase? No change or less, because the microbes are eating the nutrients. And of course, the microbes. The wash rice water is not just water and nutrients, but can it encourage microbial bacterial growth in the washed rice water. And fourth, is there any beneficial bacteria in the washed rice water? Or we don't want pathogens, but pathogen meaning they cause disease for the plants or worse for humans. And fifth, how much nutrients? This is one of the questions that is not asked often enough. How much nutrients in washed rice water are lost from soil? Because remember, washed rice water is liquid. So when we apply washed rice water, if we pour the whole pot of washed rice water into the soil, how much is retained in the soil, or how much is just simply wasted? All right? We claim that we want to save washed rice water, we want to reuse, but if we just pour the whole pot of washed rice water into our little pot, a lot of it is also wasted. So in another way, instead of throwing down the washed rice water in our kitchen sink, we throw away our washed rice water through our pot, our potted plants, because the plants cannot absorb and the soil cannot keep all the washed rice water. So this is one important question we need to answer. Number 6, ultimately, is washed rice water a good fertilizer in the short and long term? Most studies are done in the short term, just one planting cycle, 5 weeks, 4 weeks, but rarely done in the long term over several planting cycles. Perhaps the first time we plant washed rice water is not remarkable, but as the time goes on, as we continue planting, replanting, does the effect increase over time or worse, decrease over time? And ultimately, number 7, is it as good as your conventional NPK fertilizer? Number 7 is important because if washed rice water is shown to be as good as NPK fertilizer, it means that it can replace NPK fertilizer. But even if it's not as good, let's say just half as good, it's still better than nothing, because it shows that it can at least reduce the usage of or at least complement the NPK fertilizer. Okay, this is the results that I obtained. There are a lot of numbers here. This is rice grain, the solid grain. This is the amount of nutrients and the properties in the rice grain. These are the properties of the liquid washed rice water. That means when we wash the rice, this is the amount of nutrients produced. And we also, as a benchmark or baseline, we have the tap water. Remember, tap water is not just H2O. It contains other nutrients. But as you can, if you don't have to go through one by one, but you can see, if you compare roughly, quickly, washed rice water definitely has more nutrients than tap water. Tap water, because it's treated tap water, according to the national water standards, it must have low. It should have low, it cannot be high. But the pH of tap water is about neutral, 6.5. This is as it should. Tap water, washed rice water, because it's based on tap water, it also has a similar pH. EC, roughly speaking, is just the indication. EC stands for electrical conductivity. It indicates the roughly speaking, it indicates the amount of nutrients in the washed rice water. So EC is high because it contains more nutrients than in tap water, and so on. If you cannot remember your chemistry in your school, not to worry. All these symbols, these are the elements. The total N, that is the nitrogen, and this NH4 is the ammonium, NO3 minus is the nitrate. These are the available nitrogen. These are the forms of nitrogen that can be taken up by the plant. So nitrogen is a very important element. P, phosphorus, K is potassium, calcium, Ca, magnesium, Mg. These are the major nutrients, as well as S, sulfur. The last 3, copper, zinc, boron. Cu is copper, zinc is Zn, B is boron. These are micronutrients. We call it micronutrients because they are needed in smaller quantities. But this does not mean they are not important. They are very important, but just needed in smaller quantities. And you can see their washed rice water contains more nutrients. But what we want to know, what I want to highlight is the moisture. Washed rice water is more than 99% made up of water, liquid water. right? So that's why we call it water, wash rice water. This is very important. It's not solid, it's not half solid or 100% solid. It is 99%. So it acts like a liquid fertilizer. So there is a high risk of leaching losses. That means if we over apply, we risk losing a lot of that. If the soil cannot keep it, if the plants cannot keep the water and keep the nutrients, that will be lost because it's water. And the carbon content is about 3-4%. So compared with wash rice water with like palm oil mill effluent, it actually, wash rice water has lower nitrogen and lower potassium compared to POME, palm oil mill effluents, but higher C and higher C and higher P. So wash rice water, you can think is comparable with POME, but it does have lower N and K, but higher P and carbon, surprisingly higher carbon. But this is what we probably want to know, is how much nutrients are lost when we wash the rice. How much nutrients is actually lost? Most of it lost in the form of sulfur, the least nitrogen. Sulfur is by far the most, but the others is about 15, 10, 9, and so on. On average, 9%, median 8%. So when we wash rice, when we wash rice, about 9% of nutrients is lost from the rice grain, but it varies according to nutrients. If sulfur, you can lose about a third of it, about 35%, but the others is about 9%. And the next one I like to present is the effect of fermentation. On wash rice water for 0 days. 0 days means it's fresh. We freshly prepared the wash rice water, and then another one we leave it for 3 days. Then the other one we leave it for 6 days and 9 days. So we have 0 to 9. 0 is the fresh, 3, 6, 9. So if we ferment it for this long, does the nutrient content go up or go down? Another factor we wanted to study was the water volume. 1 to 1, that means we use equal amount of water to wash rice. That means if we wash 1 liter of rice, we use 1 liter of water. 3 to 1, we use 3 times more water than rice. That means we use 3 liters of water to wash 1 liter of rice, and then the most is the 6 liters of water to wash 1 liter of rice. Again, well, how does it affect? If you use more water, does it increase the nutrients or decrease, or no difference? And the next, we use the washing intensity. We go for 50 rounds per minute, 80 rounds per minute, and 100 rounds per minute for 90 seconds or 1.5 minutes. Now we wash using this food mixer. Now it's a bit strange. Of course, we don't wash rice using this sort of mixer, but we use this because we wanted to remove the variation caused by the operator. Right? Because some people wash rice more aggressively. Some people wash rice in this way and that manner. So they wash rice differently. They wash rice at different intensity. So we wanted to remove that factor. We wanted a constant way of washing rice. So that's why we use a machine that can produce this constant rate of washing intensity. So at the end, we wanted to know these 3 factors on the nutrient content, and these are the results. Now, don't be scared. There is a very clear trend. So let me just go slowly. The leftmost column is the 50 rounds per minute, right? The leftmost column. The middle column is the 80 rounds per minute, and 100 is the rightmost column, 100 rounds per minute. Now, every row is one element or one property. Now, this is the electrical conductivity, the top row, followed by ammonium. This is the available nitrogen that is important. The third is the nitrate, and P, phosphorus, and potassium, calcium, magnesium, zinc. And the x-axis is the fermentation. 0 day means fresh. 3 days means 3 days of fermentation. 6 means 6 days, and 9 days. Now, and then the blue is the 1-to-1 water ratio. That means we use same amount of water with same rice. 3, that means we use 3 times more water. 6 means we use 6 times, the triangle. Now, if you look at every graph, Generally, the longer we ferment, the graph goes up, all the line goes up. See, all goes up. Generally, some of it a bit stable, but generally, if you look from left to right, whichever row you're looking at, whichever elements you're looking at, the longer you leave it for fermentation, the nutrient content increases for ammonium, for nitrates, for phosphorus, for potassium, for calcium, for magnesium, and for zinc. So all these nutrients, the longer you leave it to ferment, 0, 3, 6, 9 days, you get higher nutrient concentration. Now, EC, same thing. That's why it's an indication of basically the nutrients in the washed rice water. You leave it longer, the EC reading also goes up, showing that the nutrient concentration goes up. That is fermentation effect. Next, we go to water ratio. Essentially, you see the triangle, the red triangle are at the topmost. Ignore the first one first. I will later discuss. If you look at the second row, third row, fourth row, then the next column, and the first, second, third, essentially they show the same thing, that the higher water ratio, if you wash using more water, you will get higher nutrients. If you use less water, like 1:1, the blue, you notice the blue is generally in the bottom, not for all, but generally you get lower nutrients. So you use more water to wash your rice, you leave it to ferment for longer, you will tend to get higher nutrient concentration. For EC, it's the other way around. The 1:1, the blue dots, and the red triangle, the 6:1, is the reverse. This is because of dilution, because EC measures the concentration. So if you use more water, obviously the concentration will be lower because you add more water. So it makes sense. But for other nutrients, the longer you ferment, the use more water, you will get more nutrients. However, there are some that is the other way. So this is more like the part 1 and part 2 of the results. For pH, the graph goes down. This makes sense. As you ferment washed rice water, it will grow increasingly acid. Remember, tap water is about 6.5. So when it's fresh, 0 days, you get about 6.5. But over time, very rapidly, about 9 days, it will decline to about 4. And there's no difference in 1:1, 3:1, or 6:1. But the stronger effect is this again because of formation of organic acids in the washed rice water as you leave it to ferment. Now, carbon and nitrogen, C and nitrogen, they have a pattern where it goes up to 3 days, and then after that, it goes down. And for copper, interestingly, the trend is quite clear that it goes down over time. Now, copper is very interesting. Sorry, before I go there, C and N is later I'll show how important they are. They will affect the amount of bacteria that you find in the washed rice water. Here is not a clear trend of it going up and then going down or going down. It's more like going up, peaking at 3 days. Then after 3 days, it will decline. I will later show that this it tallies with the microbial population. But I want to look at the copper, Cu. Cu is actually, copper is poison for the bacteria. That's why some hospitals, they have copper surfaces. Our face mask, they say infused with copper oxide, because copper is a natural antibacteria or antivirus. A lot of even snails don't like copper, and it saves cost. You don't have to wipe down using alcohol. If the tabletop is made of copper, it's a natural antibacteria, antimicrobes. But at small amounts, bacteria actually needs copper. And washed rice water contains low amounts of copper to serve as food for the bacteria. This is why it declines over time, because the bacteria are, this is my hypothesis, I cannot prove it, but this is what I read from the latest research, that at low amounts, copper is a food, not a poison. Only if it's high amounts, then it's poison. But at low amounts, copper is actually used by microbes, and washed rice water contains low enough the copper to be used by the microbes. This is why the copper content declines over time, because it's, I believe, is eaten by the bacteria in the washed rice water. So to summarize, Wash rice water chemical properties mainly affected by fermentation and the water amount you use. Washing intensity, whether you wash at 50 rounds per minute, 80, or you very aggressively at 100, it has little to no effect on the nutrient content. So what is more important is the fermentation and how much water you use. And if you ferment for longer, is essentially everything increases, or basically all nutrients except for carbon, nitrogen, which peaks at 3 days, then declines. Copper declines since day 0, and pH, because of formation of organic acids, they will decline over time. And if you use more water to wash your rice, again, it leads to higher nutrient concentration of these elements. These are more water soluble. So because they are more soluble, they will be more easily leached into the water. But the ones that are fixed, like P, they are fixed as phytate. P, magnesium, and zinc, they are less soluble. So using more water will only cause dilution. So lower P, lower magnesium, lower zinc. But essentially, all other nutrients, you use more water, more nutrients will leach. But just bear in mind, you will get lower P and magnesium. P is a very essential nutrient, same like magnesium. But boron, we find that it was not affected by any of the treatments, perhaps because rice has little boron. Now, this is also important. This is the nutrient content, just looking at the nutrient content. Now we look at the bacteria population. Oops. Okay. This is 50 rounds per minute. This is 80 rounds per minute. And this is 100, more aggressive as you go up. And this is the bacterial population. There is little difference between 80 and 100. That means if you wash your rice at 80 rounds per minute or 100 rounds per minute, it will not lead to much difference between the bacteria, but it will have greater population than 50. So if you wash your rice at lower intensity, 50 rounds per minute, this is the amount of bacteria you get, much lower than 80 and 100. So population increases rapidly at the first 3 days. When it's fresh, there's basically no difference between the bacteria population, whether it's 50, 80. But when you, after 3 days, just in the first 3 days, you get a very rapid increase in population. Then after that, it declines over time. So this is why copper, like just now, not copper, carbon and nitrogen, it goes up up to 3 days and then declines because it is taken up by the bacteria. So this means that the washed rice water can only support about 3 days of bacterial growth. For the first 3 days, you get an explosion of bacteria. But after 3 days, they will start to decline. So you leave it for 6, you leave it for 9, even lower, and perhaps if you continue to 12, you get even lower. So the washed rice water you have, do not ferment it for longer than 3 to 6 days. Because after that 6 days, or perhaps before that, the population will rapidly, not rapidly, you'll start to decline over time. So the more water you use, the lower the population. So you use less water 1 to 1, you will have higher population growth than 3 to 1 and higher than 6 to 1. So in summary, you wash aggressively, you will get higher bacteria, and if you use less water, you will get higher bacterial growth. Now, why is this so? You have to look at the carbon-nitrogen ratio. So the blue bar here is the 50 rounds per minute. The orange is the 80 rounds per minute, and the gray is the 100. So this first section is the 1-to-1 water ratio. You use less water. 3 to 1, you use 3 times more water. 6 to 1 means you use a lot of water, 6 times more water. And for bacterial growth, you need, just like composting, you need a CN ratio between 20 and 30, like indicated by this red line. Now, this is the sort of the general threshold, the general optimal level of CN ratio, carbon to nitrogen. And washed rice water contains higher CN ratio than the optimum. This is why if you use 6:1, if you look at this, look at how high the carbon nitrogen ratio is, more than 100, compared to 1:1, 40, 30, and about 21. This is why the 6:1, when you use a lot of water, the bacteria doesn't like it because the CN ratio is too high for them to grow. So they like the 1:1 because it is closer to the optimum. That is about 20 to 30. And if you look at the 50 round per minute, higher, basically the blue bar is taller than the gray bar. This one is about the same, higher the other way. But if you look at the extreme 6:1, the blue bar is much higher than the gray bar. This shows that the blue bar, the 1:1, you will have the ratio is too high. That's why bacteria loves if you use less water and if you wash it very aggressively at 100, because at 100, at 1:1, you will get a good CN ratio. The bacteria loves it at 1:1 because the ratio is about 22. If you use 3:1, it's a little too high, and 6:1 even worse, way higher. So bacteria doesn't like you wash it at 6:1 because regardless what is the washing speed, you will get your water ratio, CN ratio too high. Now this explains why if you wash your rice aggressively, like 100 rounds per minute, and you use less water, the CN ratio is more towards the optimum 20 to 30, and this is why explains the result why you get more bacteria at 100 rounds per minute, and if you use less water, like the white bar here, you get more bacteria. Okay, next, we want to identify what kind of bacteria. We only measure the population, just how many of them, but we want to know who are they in the bacteria. So this is just a picture showing the sort of, what do you call it, the media growth, bacteria media. This is 0 days, 3 days, 96 days, and 9 days. So in order to determine whether the bacteria can help us supply nitrogen, fertilizer, or nutrients, we grow them. If they turn blue, increasingly blue, it shows that they have a very strong fixation of nitrogen. That means they can supply nitrogen much easier. And you notice that the 3-day, the color blue is darker. 9 days is still blue, but light blue. Green is the natural color. That means green, nothing. P solubilization means they supply P. K, they supply K, potassium. And it's not measured by color, but the size of the halo. As you can see, these little 2 dots here. So the bigger the dot, the bigger the halo, means it has a stronger fixation, stronger solubilization, stronger, you can call it a supplier of fertilizer of P and K. So you notice that the circle, the halo for the 3 days is much bigger than the 9 day. 9 day, they sort of disappeared. Same thing with potassium. The halo is very clear, big, and during the 3rd day, but the 6th day is become smaller, and the 9 days is almost transparent. So the 3 days, this is why the washed rice water, the optimum is about 3-4 days. 6 days is already past the peak. So these are the identity of the bacteria that we have. 0 days, we only found Enterobacter species. And the 3rd day is the highest. It's not just the highest population count, but the highest diversity. We found Bacillus, Enterobacter, Klebsiella, and Pantoja. And on the 6th day, we found these bacteria. The diversity has decreased, and the 9 days decreased. So this plus means they can fix nitrogen, they can solubilize P. So some bacteria like Klebsiella, they can do all three. They can help to supply nitrogen, they can help to supply phosphorus, they can help to supply potassium. Pantoja, same thing. Stenostrophonas, also same thing. Some only can do P, some can do all three, some can do two. But at the end, basically all of these are beneficial
Microbes.
Sorry.
Yeah,
Right. Which one?
microbes. Yeah, here, here, yeah.
Here.
Yeah.
Okay.
Yeah.
Apologies for that. Well, today is going to be a long webinar. A lot of interruption. Okay, so right. So this is the how we identify the beneficial bacteria by the color. Blue is darker. The blue, that means they can help to supply nitrogen. And the halo, not color, but the size of the halo. The bigger the halo, it shows that they can help to supply phosphorus and potassium. You can see that the blue is the darkest during the third day. The size of the halo is the biggest during the third day. After that, the blue becomes lighter and the halo becomes smaller, almost disappearing. That's why when we ferment the rice, the period is 3 to 4 days. And this is the identity of the bacteria in the washed rice water. Even at fresh water, you get Enterobacter. But at the third day onwards, you get the not only the highest population, but the most the most diverse bacteria. You get Bacillus, Enterobacter, Klebsiella, and Pentoa. At 6 days, you get lower diversity, and at the 9 days, you get some similar like Enterobacter, but Klebsiella, which was present during the third day, is lost at the 6th and 9th day. And this one indicates their ability to supply nitrogen, ability to supply P, and the ability to supply K. So some bacteria like Klebsiella, they can supply all three. Pentoa, same thing, they can do all three. Some can only do two. They can supply N and they can supply P. And some can only supply P and K. Right? But they all do something. It's nothing is all dash dash dash. So this is the identity of the bacteria. But I need to stress something. That Klebsiella, Stenotrophonas, and Pentoa, they are beneficial for plants, but for humans at high amounts, they can cause pneumonia, they can cause respiratory, urinary, and even meningitis. And Pentoa, they are beneficial, but at times they can cause diseases in certain crops. But all this, I like to stress, just because they are present, it does not mean they are a health hazard, because these are very common bacteria found in the environment, in the soil. Don't be surprised, you can find them even in your kitchen and toilet. Again, just because they are there does not mean washed rice water is harmful or a health hazard. It just means they are there, but at low amounts, they are probably not dangerous. Like Klebsiella is a good example. Klebsiella, if you look at the previous slide, they are only found in the third day. After that, the 6th and 9th day, they are no longer present. Okay, so just keep that in mind. This is put it in mind that Klebsiella, Stenotrophonas, and Pentoa, they can cause human disease, but the risk is very low. But you just need to keep this in mind. And besides NP and K, the bacteria can also supply a very important hormone. We call it IAA, or indole acetic acid. Again, the highest is at 3 days. After that, it declines at 6 and then 9 days. So this indole acetic acid is a plant hormone. In school, you probably learned it as auxin, and very important for plant and root growth, particularly for the roots elongation and root hair. So washed rice water should be beneficial to promote root growth, particularly the roots. So it's not just NPK, but auxin as well. Now, the next one, we wanted to learn how much nutrients is lost from the leachate. That means we set up an experiment. There's a tube. We put it different kinds of soil, about 30 centimeter deep, and then we pour washed rice water, and we see how much came out and what came out, how much water came out, and how much nutrients was lost. Preferably, ideally, what we put into the soil stays into the soil. But we know that it's not true. Some will come out. And the clay soil contains a lot of clay. The silt loam soil contains a lot of the silt. And the sandy loam contains a lot of the clay. So as expected, a lot of sand sand. A lot of sand, you have a lot of losses from what you put. The least is the silt, but and the amount of water, the clay is near saturation. So the clay soil, this shows you the importance of not overwatering. We have, because we put the flat rate across all different soils, so the amount of water and the clay is basically over 8 weeks is saturated. It's too much water. Sandy clay is all right. We want it to be about the green line, field capacity. This is a good target to achieve. We don't want it to be lower than the red line, because the red line means a lot of, that means the soil is too dry. We want it to be near the green line. And you can see basically they are overwatered because there are no plants, it's just soil. Sandy clay is about right, but they lose a lot of water. But what is important is the next slide. For this nitrate, ammonium, P, K, calcium, magnesium, a lot of nutrients from the washed rice water is lost from P, phosphorus, potassium, and magnesium. You can see here 100%. That means they lose more than what we add. We don't want it, ideally we want it 0%. That means nothing is lost. What we put into the soil stays in the soil. That's 0%. But most of it is quite low, about 25, lower than 50. But except for these three nutrients, this phosphorus, potassium, and for magnesium, they are above 100%, especially for sandy clay loam. That means for sandy clay loam, if your soil contains a lot of sand, you risk losing a lot of P, K, and magnesium. Same thing with other soils, but not above 100. So for sandy clay loam soils, you are going to lose more than what you add, especially for nutrients P, K, and magnesium. And these are three essential nutrients for our plants. So this is just to show you that washed rice water, you have to manage it. You shouldn't just pour the whole pot of washed rice water into your soil. That is as good as basically pouring down the kitchen sink, because these are, you're going to lose more than what you have added into your pot or your field, or PK and magnesium, particularly if your soil contains a lot of sand. If you're clay, you're all right. But clay, the problem with clay is like this slide, you tend to overwater. So this is again a problem, not a nutrient problem, but a watering problem. You have too much water in the soil, containing a lot of soil, a lot of clay. Okay, so this slide shows that sandy clay loam soil already contains low amount of nutrients. So if you lose these nutrients, it's going to cause even water nutrient deficit. So you don't want to lose what little that you have. You want to keep them. They already have low nutrient content compared with silt loam and clay. You don't want them to lose even more nutrients. Okay, lastly is the crop growth experiment. We use a vegetable test crop, a very common vegetable, choysam, Brassica chinensis, sometimes called Brassica rapa, and they are grown on three types of soil. The same soil just now I discussed: clay, high in clay; silt loam, high in silt; and sandy clay loam, very high in sand. And we use 3 planting cycles. That means we use the same soil over 3 planting. 3 times we plant, we harvest, we plant again, we harvest, and then we plant for the 3rd time and harvest. And these are the treatments. We use control, only tap water, no fertilizer, just plain tap water. RW0, this is unfermented or fresh water, fresh washed rice water. RW3, that means rice water, 3 days fermentation, and your normal NPK fertilizer at the standard rate of 68, 10, 96. And we water them at a constant rate of daily 5 millimeters. And then and this is the experiment under the rain shelter. And why we did it under the rain shelter, not over the field, under the field or in the field, because we wanted to control the amount of water received by every crop, and we also want to do the leaching. You can see there's a plastic bag at the bottom. Is to collect the leachate coming out from the different trays. This experiment, the data is still being we are still analyzing, but I'm presenting what we have, right? So these are just some pictures showing of the trial. They're all randomly located. It's not one row all clay, one row all sand. There must be some randomization, and some shows good growth, some shows not so good, and so on. And these are some pictures. Again, don't rely on pictures. They can be deceiving. Sometimes they look small, but they're heavy. It's just a picture. This again, just to remind you, RW0 is unfermented, fresh. RW3 is fermentation after 3 days. NPK is your usual NPK fertilizer. CON is just tap water, nothing but tap water. And this is for case of silt loam. You can see there really some difference. Right? Please keep note how similar RW3 and NPK look like. Right? So they look quite similar. Just visually, just to look visually. Visually are again, these two look alike, the 3-day fermentation and normal fertilizer. The fresh doesn't look as good. And again, and this one, this is for the sandy clay loam soil. Now, we found that the sandy clay loam soil, like the leaching experiment, the leaching tube, it had no effect. It means the sandy loam soil probably because of too much leaching losses. Now, again, this graph looks complicated. I will slowly go through one by one. The leftmost is the clay soil, middle is the silt loam, the rightmost is the sandy clay loam. And the first row is the leaf area. Preferably, we want big leaves. And the second row is the leaf weight, leaf dry weight. Again, we don't only want big leaves, we want heavy leaves. When we go to the market, we go for big leaves and heavy leaves. And this is the total weight, including the leaves and everything above ground, not including the roots. So, if you look, the CON, the red dot is always below. That means control, no surprise, is the worst. That means because they don't receive anything, they don't receive any nutrients, we don't expect it to perform as well as the other treatments. So all the red dots are all in the bottom. But you look at pay attention to the blue and the purple dot. The blue dot is the NPK, the purple dot is the RW3, fermentation after 3 days. Or for all soils, except for sandy clay loam, for clay and silt loam, the blue dot and the purple dot are no different, basically no different from each other. Essentially, generally, there are some difference here, but generally they are same. That means, and the third cycle, this is the first cycle, second cycle, the third cycle. The third cycle is very different from the first and second cycle. This shows that the third cycle, you start to see the strong effect of the treatments. Even the control has a stronger third cycle but the highest is the NPK. So if we had just stopped our experiment at the first cycle, we may report less than impressive results. So we may just say, well, it's okay. But if we continue until the third cycle, we start to see big differences between the NPK and the wash rice water and even with control. So the third cycle, you start to see generally the wash rice water, 3 days of fermentation is just as good as your NPK fertilizer and all better than control. And the sandy clay soil is the worst. Sandy clay loam soil with a high sand content, very little difference between treatment, probably because of the high nutrient losses as showed previously. So if your soil has a lot of sand, you might report less than impressive result for wash rice water. You may say that, well, it's a myth that wash rice water is beneficial because I planted in my garden, which has a lot of sand, and I got not so good results, just as good as pouring tap water or with my NPK fertilizer or if I don't add anything. But if your soil is clay or contains less sand, not so much sand, you may start to see big differences. Particularly, you may find that your fermentation after 3 days is just as good as NPK. So again, number of leaves, you want a lot of leaves and you want high chlorophyll, high nitrogen, not too much nitrogen, but this indicates the growth. So just in terms of number of leaves, there's no difference between fresh 3 days fermentation with NPK. But again, all better than control. Same thing with chlorophyll content. The plant height, more or less the same story, regardless of your soil. The fresh 3 days is just as good as the NPK. But plant height is not an important property. We don't usually go for the tallest plant in the market. We look for the biggest leaf and the heaviest plant, not so much on tall plants. Okay, now why is the wash rice water beneficial? Mainly because of high P and high K. There was no clear trend for the other nutrients, but what we found that plants with receiving NPK and wash rice water third day, they have higher P and higher K. This is why the plant grew much better in NPK and RW3, particularly in the third planting cycle, because they took up more P and more K. And just to summarize all the results, let me just read. About 0.4 to 35% of nutrients are lost when we wash rice. The average is 9%. And washing intensity has little to no effect on the nutrient content in wash rice water. So how much you wash, whether you wash it aggressively or not, it will not affect the nutrient content by much. What is more important is how much water you use to wash the rice and whether you ferment. And again, the best fermentation is 3 days. And the more water you use, basically you will see large increases in almost all the nutrients, except for P, magnesium, and zinc. And if you ferment for longer, like the wash water, you will get almost higher elements for all nutrients. Of course, because of acid formation, you will get lower pH. And C and N, they will rise at until the third day and then decline. Copper will decline all the time because of bacterial use. Oops, wait. Oh. And the bacterial population is maximum at 3 days. After that, they will decline. So wash rice water can only support of 3 days of bacterial growth. You will get the highest population if you wash intensively, more or more aggressively, and if you use less water. So you wash more aggressively and you use less water, you get higher population. Again, this contradicts the other one. You use less water, you are going to get less nutrients. So there is a trade-off. If you use less water, you will get higher bacterial growth, but you will get less nutrients. Right? So that is a bit of trade-off there. Bacterial diversity is the greatest when at 3 days. Not just you don't just get a lot of bacteria population growth, but you get more diversity, and these are the identified bacteria. And they all can supply nitrogen, phosphorus, and potassium, as well as the oxine. And salts, keep in mind, salts with high sand content, they lose a lot of nutrients, particularly the essential nutrients of phosphorus, potassium, and magnesium. So for salts with high sand content, it's very important. You manage your soil, like adding mulch or organic matter, to conserve the water and to reduce the drainage loss of water, drainage losses of nutrients. And you will get stronger effect on plant growth over the long term. And we found that the fermentation 3 days is just as good as NPK fertilizer. And in some cases, there's no difference between fresh or 3 days fermentation with NPK. But all, of course, better than control. Right? But soils, if your soil has high sand content, you may see less than impressive results compared with your neighbor who has less or lower sand content. And plant growth increased because they took up more P and K. So the conclusion is use 3 days fresh water, wash rice water. It can be as good as NPK fertilizer. Over a much longer term, maybe over several months or to a year, perhaps we may find that wash rice water may actually be better than NPK. Why? Because they can build up bacterial growth in the soil, beneficial bacterial growth, and they can help to fix ants, help to supply P, K, and as well as IAA, with something that the normal fertilizer cannot do. But please bear in mind, wash rice water is almost all liquid. Because it is liquid, we can easily cause high leaching and drainage and loss of nutrients, particularly if our soil has a lot of sand. Right? So if you pour a lot of wash rice water, don't expect it to stay in the soil, especially if it has a lot of sand. you may lose a lot of nutrients by that way. So washed rice water has to be, but please take note, washed rice water has to be applied continuously every day, daily, or perhaps once every few days. But NPK, on the other hand, is only applied once before planting. So this is probably one benefit of NPK. We may say that washed rice water is just as good as NPK, but the benefit of NPK, if you want benefit over, is you only do it once. You apply the fertilizer once and that's it. Whereas washed rice water, you have to always add it, and that's one drawback. So thank you very much for your. I apologize again for the delay due to the hiccup. Before I receive questions, if there's time, I'd like to promote this book. It's on sale now by UPM Press. There's a 20% discount now, 25 ringgit 20 cents. This is a book aimed for gardening enthusiasts that answers the FAQ, the questions that I'm commonly hear, or I listen, or I get, or I read from other posts. So these are questions such as how much water to apply, what is the difference between organic and inorganic or mineral fertilizer, and so on. And even this wash rice water topic is added. So you can buy it at the UPM Press. Take down this address. So, okay, thank you very much.
Okay.
Okay.
Thank you very much, Luther, for your informative sharing just now. So now we have a question from Mariam.
Okay, should washed rice water be fermented in a container and covered? Yes, just like that Indonesian, the first few slides. But you cannot just completely seal it because the gases that is produced has to go somewhere. So that's why they attach it to if you remember, there's a jerry plastic bottle. Then there's a tube from the top to they connect it to a water. They submerge the end of the tube to water. That is to allow the gas to escape. They seal it because they don't want air to go in. They want air to come out. So you need to make some holes. But it's okay. In our experiment, we didn't do those things. We just let it out in the open air in the room. Of course, we covered it to avoid evaporation, but it's not to say airtight. So yeah, if you can cover it, good. But please allow air to go out.
Okay, thank you, Mariam, for your question. Next question, Doctor, from Kwan Chow.
What other common household discards have been studied for their effects on the soil microbiome? Spot milk, moldy bread, yeast flour, beer pickles made from kimchi and tempeh. Well, I have read they add washed rice water with common household. You mean not added with washed rice water? Again, all these things are probably studied, but not at a very detailed level. But for washed rice water, they some experiments they add milk. Yes, they add milk and other things as well. But again, all this is part of reusing wastewater. Even your laundry wash, the water that comes out after laundry, like Dr. Susi.
Yeah, correct.
Right.
But if I could comment on this, I think there will be possibilities for all the gardeners to utilize it. But for us in UPM, I think currently we are working with washed rice water, and also for me, we are using for washing machine disposal water.
Yeah. So
So,
that water
but
that comes out of the washing machine, it just goes
correct.
down the drain. So can you
Yeah,
use it? What issue of that is the soap. Soap contains salt, and it's not
yeah.
so.
So basically, there will be some benefits on utilizing all these ways,
Yeah.
right?
Okay.
Yeah. Thank
Any
you, Mr. Kwang, for your good question. So, yeah, from Carol.
any study on fermented water with cooked rice? You mean you cook the rice and then you ferment it? At the moment, I think no, not again. Wash rice water. As I said earlier, there are only 41 papers worldwide, not 41 papers in Indonesia or Malaysia. So there's
Mhm.
very little study or great variety. So it is, yes, a possibility you cook the rice and then you ferment it.
Mhm.
And is it better than using uncooked rice? Yeah, but the one we did was uncooked rice. Yes. There have been evidence. They have evidence data from wash rice water that was applied to plant like vegetables, where they have effect on their growth, like biomass, leaf area, and height. Yes, I just presented. Yeah, there is evidence that shows that, like for my experiment choice sum, the leaves are bigger and heavier, and the total weight is higher. But it depends on the soil. Soil with high sand content, you may not see a very impressive result. Even if you get better, it's not to say as good as others, or you may not get any result at all. Right? So there is evidence. Okay, mold growing on the plants. This is again, just because you see mold doesn't mean it's bad. All right. If you see molds, it's probably because the area, maybe because it's too shady or too wet. So maybe you have applied too much water, or like wash rice water in the area. So you need to, I don't know about your area. You need to open up the area, maybe reduce the density. Like if you use in the pot, you may have to put in the pot in a warmer place and put further the distance between pots so that it's not so cramped. But if it's in the field, if you have mulch, like if you add something on top, you may have to remove those mulch to reduce the wetness so you don't get mold. But again, just because you see mold doesn't mean, oh, this is bad. Okay, it can be beneficial, but it's an indication that the area is a bit dark and a bit too wet. Maybe you have applied too much. So try to reduce your application of wash rice water or and watering. All right, thank you. What if we soak rice grain in water? Will the effect be the same? What do you mean by this? You mean is we here? If we
If we
soak,
soak just now you are talking we washing. Now they want to soak the rice. Is there any effect on that?
okay, that's
Yeah.
one area to study lah.
Yeah.
That's one
But
area. Yeah,
yeah, but
probably
currently the result is related to the washing.
yes. Just
Yeah.
immediate washing and reuse. But yes, I intuitively we think that if you soak it, you leave more time for the rice, the grains, I mean the nutrients to be leached out. So we expect more nutrients. But again, I want to stress, like one reviewer asked, wash rice water here is not to compete with food. Okay,
Mm-mm.
it's not eat rice either for rice or use for wash rice water. It's just that when we wash the rice, what do we do with the water? That's all. It's not to wash it in such a way that we get maximum nutrients until the rice we eat contains zero, nothing. It's just eating solid mess only. So it's not that is not. Of course, we don't want a case where the nutrition goes down and then we get very rich wash rice water because all the nutrients lost. And we don't want that case. It's not to compete with food. It's just a way whether we can. Is it worth the time to reuse the wash rice water? Yes. Okay. For that tree cycle, do you use the same media? Yes, we use. That's the idea. We use the same media. We don't change. Or do you replace? No, we don't replace. We use the same media because we wanted to see over the long term using the same media. Does it have an effect or not? We don't replace. We don't do anything. Okay. The neutral effect by temperature. This is one area we need to study. We did it in the room temperature. We fermented in under the room temperature of about maybe 25, 26, 28 degrees Celsius. About that. Not out in the sun, but we did it in a room temperature. Okay, but yes, it's interesting to see will it have an effect. Or if you leave it in the fridge, does it have an effect? I think it will because it affect the bacterial growth. Yes. Is there any difference in the amount of nutrients with the type of rice that you are going to use? Yes. The amount of nutrients depends on the rice variety, how the rice is being prepared and milled, and whether it's white rice, brown rice, or red rice. Because brown rice, we don't remove the outer layer. White rice, we remove the outer layer. But remember that brown rice, the outer layer is a bit like a waterproof seal. So when we wash the brown rice, even though the brown rice contains more nutrients than the white rice, we may find that the brown rice water contains less nutrients because that outer layer protects the rice grain, the nutrients from being lost. So you may get lower nutrient content. In fact, in an earlier study, I found brown washed rice water, that is washed rice water from brown rice, containing less nutrients than the white rice water. Again, I just it's not to compete with food. It's not. Please don't get in mind that this study is to maximize the nutrient
Yeah.
extraction from rice
Yeah.
grain.
Yeah. Very true. Yeah.
Because we don't want that. We don't want to eat
Yeah.
nothing. But our plants are surviving, but we die because we
Yeah.
eat nothing.
Yeah.
All right.
Basically, we want to utilize all the waste that is available in our surroundings. So then we
Okay.
can share with the data with our audience. Okay.
Okay.
Any other question from Facebook?
We have a variety of rice, brown rice, Thai rice. Which one? Okay. Or this one, as I said, it's a study by itself, just to study all the various rices, various brands, because it depends on the rice variety. That's one. If the rice variety has lots of nutrients, obviously more will come out. But who knows? And brown rice as well. And the Thai rice, short rice, long grain rice, medium. We use medium grain. That is a study by itself. But what we have done so far is brown rice with white rice. I didn't present the result. If you wash brown rice, you will get lower nutrients because of the protection the outer layer, the brown rice gives to the grain itself. So you will get lower nutrients using brown rice. But we eat more nutrients, so it's still win-win in a way. All right. Next, I put carrot skin, potato skin on top of salt. Wash rice water to wash the veggie, but the plant grows most. Okay, this basically answers your previous question. You have to probably look at your environment, aerate the place, make sure more oxygen, more air flows through the environment, or put your plants in a slightly warmer place to reduce the growth of mold. Right?
But I think for this question also, it is related to the use of you put your carrot skin and potato skin directly to the soil. There will
Mm.
be if you put at the top, there will be retention of moisture will be in the top of your soil. That's why the
Yes.
mold is coming out. If you want to put the carrot skin and also potato skin, you must cover with the soil. Then it will be better.
Yeah.
Yeah.
Okay, good.
Yeah.
Thank you. Dr. Suzy. Yes.
Yeah. Yeah. Yeah.
Okay, next. Any more?
So any other question?
Ui, lot of question, three in one. Yes, yes, just wash away. Yeah, you can wash away. Or cut off the layer. Yes. But please bear in mind, mold doesn't mean bad. It's not to say mold something wrong with your plants. We cannot say it's good. We cannot say it's bad. It's just indication that the area is quite moist. The humidity is high in that environment. It could be indication of that. All right. Okay. Is that all? Is that all? I think that's all. Anyone wants to ask verbally? Nothing. So okay. Thank you so much for.
Yeah.
Okay, thank you so much. I would like to thank the Faculty of Agriculture for hosting this, giving a channel, and I apologize for the. I do not know sure what happened just now. There was a internet connection. I was talking for so long, still talking. Nobody talking to myself. Okay, right. Thank
Okay.
you so much. Okay, thank you very much.
Okay, so we'd like to thank Associate Professor Dr. Christopher for giving a very informative webinar today. So if you have any suggestion for us to go through, the special topic that you want for us to cover, you can put in the comment later on. So we appreciate your participation for this webinar today. So enjoy your weekend. So see you for another webinar. Inshallah, we will organize more. To please comment for this
Okay.
webinar. Okay, and give your support to the. We are sharing more lah. If you give a suggestion to us. So thank
Okay.
you all. Enjoy your weekend. Okay, bye
Okay.
bye.
Thank you. Bye.